Buonasera, everyone. That's good afternoon in Italian. So today's video is going to walk you through the notes on how to substitute and solve a system of equations. So the objective of this is to actually model a system and be able to solve it algebraically. Instead of graphing, this is the algebraic way of doing things. As you can see, my smartboard is busted, so we're working on whiteboards today. And all it is we're going to be working through this sheet of paper. I'm going to give you all of this, and then at the end, I want you to be able to do the back as practice and come into class ready. So this is the same cell phone plan question that we did with the graph. I'm going to show you how to solve it algebraically. So to recap, we have two plans. The first plan charges $15 plus 20 cents for every minute, and the second plan charges $30 plus 10 cents per minute. So to write the two equations for this situation, again, this is my B, that's my starting point, whatever I pay no matter what, using no minutes or anything. And then this is my rate, or my M, because it's changing. So as I use more minutes, this number goes up. So that is my M. So I'm just going to call this plan A. I can write an equation, y equals 0.2 or 0.20 x plus 15. For plan B, okay, again, this is my starting point. This 30 is my starting point, and this is my rate. So I would write y equals 0.1 x plus 30. So I have those two equations, and they are the ones that we used for graphing. Now, the part B asks you, when will the plans be the same? So the same means equal in math terms. So we have to figure out when these are going to be equal. The best part about this is they're both solved for y. So what I do is I say, okay, this plan, y equals 0.2 x plus 15. If y equals this quantity, well, it has to be the same thing as that. So all I do is I take these two equations, 0.2x plus 15, and I make them the same, equals 0.1x plus 30. And now it's simple algebra. Okay, I'm going to subtract 0.1x. I'm also going to subtract 15 at the same time. Save on some steps there. So I get 0.1x equals 15. And now I divide by 0.1, and x equals 150. So again, x, okay, because it's next to the minute, the 10 cents per minute, 20 cents per minute, this is the 150 minutes. Okay, so for 150 minutes, that's my x value. Now I have to find out my y value, because remember, a system is always points. So I take this x and I choose an equation. Well, I'm going to choose this one, okay? It doesn't matter, okay? I can just choose, okay? So what I'm going to do is I'm going to take this and I'm going to say, okay, y equals 0.2x plus 15. That's my plan A, okay? That's not showing up. Y equals 0.2x plus 15. Well, now, all I do is I take this 150 and I plug it in for x. Y equals 0.2 times 150 plus 15. Then I multiply. So that's 30 plus 15, so that's 45. So again, when will they be the same? At 150 minutes, it'll cost me $45. So now we go to part C, Which plan is better? Well, they're the same. At 150 minutes. Okay. Before that, plan A is better. After 150, plan B is better. But we have to make sure that we're solving for both x and y and plugging it in. So this is a situation where we need to solve a system. The next examples are going to be where we give you two equations and you're going to have to solve for x and y. So these are the top two examples for substitution. Substitution method actually tells you exactly what you have to do. If you're going to substitute something in, you're taking one thing and replacing it with the other. So in this case, I have two equations. I have this y equals 2x and this 4x minus y equals negative 4. And we want to find out when they're the same. So since I have y equals 2x, I know y equals 2x. So what I'm going to do is I'm going to take that and I'm going to put it right in there for y. So now I rewrite this equation with y replaced with this 2x. So I have 4x minus 2x equals negative 4. Well, now I just have my x's. Now I can combine. 4x minus 2x is 2x equals negative 4. I can divide by 2. X is negative 2. So now I've found my first part. Now I have to take this and I have to plug it into one of these equations to solve for y. My suggestion, you'll get the same answer no matter what, is to take this negative 2 and plug it in here. Because it's already y equals. So y equals 2. Now, instead of x, now I'm going to put in negative 2. Okay. So now 2 times negative 2, well, that's negative 4. So the intersection, or the point that is common, is negative 2, negative 4. So substitution takes one equation and plugs it into the other. But the first step you have to do, always, the first step is to solve for a variable. So here, when we don't have like a y equals, like in this one, we have to choose a variable to solve for. So in here, well, this is a 2x, this is a 4x, this is a negative 6. I could solve for any one of those to get y alone or to get x alone. But we want to make it easy on ourselves. So do you see how this x just has a 1 in front of it, right? There's nothing there. So if I'm going to solve for a variable, I want to make it easy. I just want the one that's alone, so I don't have to divide. So I'm going to take this x plus 3y equals 7. I'm going to solve for x. I'm just going to get rid of this 3y. And I'm going to get x equals 7 minus 3y. Alright, I got x alone. Now to solve this system, all I do is I take this x, this equation right here, and I'm going to replace it, put it in to this x right here, into the other equation. So I'm going to get 2 times 7 minus 3y minus 4y equals negative 6. Now all I have are y's. So I'm going to distribute 14 minus 6y minus 4y equals negative 6. Combine my like terms. 14 minus 10y equals negative 6. Subtract 14 both sides. Negative 10y equals negative 20. Divide by negative 10. Y equals 2. So I got y. But now I have to find x. So what I'm going to do is I'm going to take this y and I'm going to plug it into this equation right here. You can plug it into any one of them, but I've already solved for x. So I'm going to make it easy on myself. So I'm going to take this y, alright, x equals 7 minus 3 times 2. Well, 3 times 2 is 6. 7 minus 6 is 1. So now my point, the solution to this equation is 1, 2. This is my x, this is my y, so 1, 2. One last example just to hit it home. So remember, when you're given two of these, the first step is always to solve for a variable and make it easy on yourselves. You don't always want to solve for y, you don't always want to solve for x. You want to solve for the variable that doesn't have anything with it. It's just 1 in front of it. So in this case, this x has a 2 with it, this one has a negative 1, this one has a 3, but this one's all alone. Just the 1 in front of it. We can solve this really easy. So all we're going to do is we're going to take away 3y on both sides. So now I get x equals negative 6 minus 3y. What I do with that, I take this x and I'm going to plug it in now into this top equation x. Okay? Remember, it's if I solve the bottom one, I'm going to plug it into the other one. Okay? So, 2 times negative 6 minus 3y in parentheses. Remember, it always goes in parentheses. Minus y equals 9. I distribute. Negative 12 minus 6y minus y equals 9. Then I get negative 12 minus 7y equals 9. Add 12 to both sides, negative 7y equals 21. Divide by negative 7, y equals negative 3. I found my y. I then take this y and substitute it in here. Okay, so I get x equals negative 6 minus 3 times negative 3. Well, remember, negative times a negative is a positive. Negative 6 plus 9 is 3. So that's what x equals. So my solution point is 3, negative 3. So those are the 4 examples of how to solve for substitution. Try the problems on the back, check your answers, and be ready to go next class.